Welcome back to IronHand Tech. Every year, more than 1 billion tires are thrown away worldwide. That's more than 15 million tons of rubber, enough to circle the Earth several times. But guess what? Many of them aren't really finished. They just need a major overhaul. Welcome to the world of tire retreading, and especially the handmade version, where experienced hands, keen eyes, and generations of skill create new rubber warriors from old carcasses. Tires are more than just rings of rubber. They are the shoes of every machine, from the humble tractor to the giant excavator. And like all shoes, they wear out. Not just a little, but after hundreds of thousands of revolutions on hot roads, mud, gravel, and ice. But beneath that worn tread, the carcass, the rubber skeleton inside, is still strong, and that's all it takes to be reborn. Retreading is like giving a tire a spa treatment with a little surgery. And while high tech has automated everything, there are still small workshops where everything is done by hand. No robots, no scanners, just hands. In a large factory, this step uses X-rays, ultrasound, and heat sensors. Here, we have a more powerful weapon, the worker's intuition. They touch, they knock, they look closely at every crack, every blister. Experience allows them to distinguish between a usable tire and a tire that has reached its end. Did you know that each retread tire saves about 75 liters of crude oil compared to new production and reduces CO2 emissions by up to 70% compared to new tire production? Once the tire is determined to be in good condition for regeneration, it will enter the first molting stage, grinding off the old worn rubber layer. The worker uses a specialized grinding machine, either a handheld machine with a large grinding stone or a semi-automatic machine, to completely remove the old tread layer and the rubber layer on the outside. At this point, the tire changes from a rough, black surface to a smooth, even surface, ready to adhere to the new layer. Grinding is not as simple as peeling a potato. It requires high precision because grinding too deep will weaken the frame structure. Grinding too shallowly will cause the new tread layer to not adhere firmly. The grinding depth is usually determined by the type of tire, but will generally be between 2 to 5 millimeters. The surface after grinding must be smooth, clean, with no signs of old rubber, no bumps, and especially no rubber burn marks, a sign of grinding too hot. In addition, during the grinding process, the worker can also detect abnormalities such as peeling, blistering, or deep cuts. These points will be marked for processing in the next step. After the old tread is polished off, the tire will reveal small defects, tiny cracks, pinholes, cuts from sharp stones, or weakened rubber areas. These wounds are small, but if not treated thoroughly, they will cause the tire to pop, leak air, or break during use. After finding the defects, they use a slow-rotating drill to clean the defective area, removing all dirt, rotten rubber, and shaping it into a circle or ellipse for easy patching. Then the worker uses reinforcing materials such as rubber plug-ins or even a layer of compensation to ensure uniform thickness. Imagine this is an emergency room, where old wounds are treated carefully and thoroughly in preparation for the next step of cosmetic surgery. Because the tire may be old, but it is not allowed to be weak. Once the tire has been cleaned, flattened, and thoroughly repaired, it is time to put on a new coat, the rubber tread. The worker will use a new strip of pre-shaped tread, usually a partially vulcanized rubber, pre-cured tread. This strip is measured and cut to fit the circumference of the tire. The surface of the tire frame is coated with a layer of specialized glue, usually a highly vulcanized glue, ensuring strong adhesion to both the old and new parts. Next is the step of wrapping the tread strip. The worker presses the tread layer tightly onto the tire surface, aligning it so that it is even across the entire circumference. They use their hands, a hand roller, or a simple rolling machine to gently press, avoiding creating air bubbles inside. Some places will use a tightening wire or an external steel mold to keep it stable during the preparation for vulcanization. This is an extremely important step. If the patching is not even, the tire will vibrate, shift, or quickly fail after a few hundred kilometers. Therefore, care and attention to detail are required. When finished, you will see that the tire has been completely transformed, ready to enter the sauna room in the next step. Now comes the chemistry. The newly patterned tire is placed in an autoclave, a device that resembles a giant pressure cooker or autoclave. Under high pressure and constant temperature, usually 150 to 160 degrees Celsius, vulcanization occurs. The rubber molecules in the adhesive and glue combine with the old frame to form a strong chemical bond. This is when the tire becomes a single unit, no longer two separate parts. In artisan workshops, autoclaves can be powered by electricity, gas, or even wood, and there is no automation. The workers monitor the process with a mechanical watch, a pressure valve, and their own experience. They time it down to the minute, checking for every sound and smell of rubber to determine that the process is going smoothly. A vulcanization cycle can take 2 to 4 hours, depending on the tire and rubber used. After the process is complete, the tire is either allowed to cool naturally or force cooled by fans or water. A retread tire can last 90% of a new tire at a fraction of the cost, which is why in the US, retreads save the trucking industry more than $400 million a year. Next time you see a truck climbing a hill, a tractor plowing through a field, or even a plane landing smoothly, who knows, the tire beneath its feet might have been reinvented. Retreading isn't glamorous, but it's smart, cost-effective, sustainable, and technically sound. In a world filled with trash, it's a simple and powerful way to extend the life of a product. Because sometimes moving forward, all it takes is a little old rubber, properly reinvigorated,